Good morning, everyone. So, first of all, you can you can send your attendance. Puneet, good morning. Rest of the students, you can also send your attendance. So, I have a few questions on the board. You can, Deepak, good morning. Find first question. Find the roots of the following equation. One is x minus 1 upon x is equal to 3, where x is not equal to 0, and the second equation, that is 1 upon x plus 4 minus 1 upon x minus 7 is equal to 11 upon 30, right? So you have to find the roots of these equations, and second, you have to factorize. We have 5-6 parts. Factorize these polynomials. You can factorize in any way. You can use even splitting middle term. Jaswinder ji, good morning. So you can start solving. First one, it becomes a quadratic one. When you multiply the equation here, so here it becomes x square minus 1 upon x equal to 3, and x will go right side, it will become 3x. So equation will be a quadratic one, and it's up to you. If you want to solve with the help of completing square method, you can solve with completing square method, and if you want to solve with the help of quadratic formula, you can solve, because here the examiner is interested to find the value or find the roots of the equations. Okay, so both equations we will solve here. You can also start solving. You can send your solutions if so. First part here, that is when we take LCM is x square, because LCM is x, so we have x square minus 1 is equal to 3. X square minus of 1 is equal to 3, and when we cross multiply and rearranging, this implies that x square, right, x square minus of 3x, even if possible, if you can split by middle term, if possible you can even find by splitting middle term also. But here, because sum and product, if it is difficult, so you can go with the quadratic formula. Quadratic formula says that the two values will be minus b plus minus under 2 b square minus 4ac upon 2a. Quadratic formula says that the two values, the roots of this quadratic equation are equal to minus of b plus minus b square minus 4ac upon 2a. So what is the value of a? In this first part, a is 1, b is minus 3, and c is again minus of 1. So here the two values of x, they are minus of b, minus will become plus. So here plus minus, b square is 9, minus of 4ac, minus of 4, a is 1, c is again minus 1, divided by 2a, 2a means is 2 only, a is 1, so here 2a is 2 only. So we have the value, two values of x, they are 3 plus minus under root. So here that is 9 plus 4, that is 13, and divided by 2, right? So here no one has sent me the answer. First part, the value of x, they are, one is x plus under root 13 by 2, and the another value of x, that is 3 minus under root 13 by 2, right? So you know the value of under root 13, under root 9 is 3 and under root 16 is 4. So value of under root 13 will lie between under root 13 is less than 4 and greater than your 3. So we will substitute the value of under root 3 and we will find the both values of x, right? One is 3 plus under root 13 upon 2 and another is, so second part, that is here 1 upon x plus 4. Go on solving the second part in the same way. Solve first the equation, make in the standard, write in the standard form, and then find the roots. Find the roots of the equation. So here, when we take the LCM, so here LCM will be x plus 4 into x minus 7. X plus 4 into x minus 7 is the LCM. And here we have then x minus 7, right? And here we have minus of x plus 4, right? Which is equal to, later on I will cross multiply with, but we will solve it. So here we have, that is, when we solve, we have x minus of 7 minus of x minus 4. So x and x get cancelled. Here this is x square minus of 3x minus 28, right? It is x square minus 3x plus 28, right? So here we have, that is minus 11. We have the equation, we will start the equation, that is minus of 11 upon x square minus of 3x minus 28 is equal to 11 upon 13, right? So here 11 and 11 get cancelled, minus sign remains. So we have, when we cross multiply, we have x square minus of 3x minus of 28 is equal to minus 30. Cross multiply. So what we have? So we have the final equation, that is x square minus 3x, here that is plus 2 is equal to 0. Plus 2 is equal to 0. So here we can solve with either way. Now this quadratic equation, A is 1, B is minus 3 and C is 2 here. So you can, we can check with splitting middle term also, 2 into minus, yes, we can solve with the help of splitting middle term also. So splitting middle term, let's check if it is possible. Then this implies that x square minus of 2x minus x. 3, 1 into 2 is plus 2. So here this implies that wait. So here, not in this way, we can rearrange here x first and 2x, x first minus of 2x in this way. So we have x, that is x common, x minus 1, right? And here x minus 1, and here we can take minus 2 common also. So we have the two roots, two factors, one is x minus 1 and one is x minus 2 is equal to 0. How to find the zeros? Either x minus 1 is 0 or x minus 2 is equal to 0. If x minus 1 is equal to 0, then x is equal to 1, and x minus 2 is equal to 0, this implies that x is equal to 2. So, for this equation, we have the value of x is equal to 1 and the value of x is 2. This quadratic equation we have, so it seems very complicated. 1 upon x plus 4 minus 1 upon x minus 7 is equal to 11 upon 30. So what we have done, first we have taken the LCM, after LCM, and then cross multiply. Here we got minus 11, 11 and 11 get cancelled, so it becomes minus 11 and 11 get cancelled, and here denominator we have x square minus of 3x minus 28. So here 30 will become minus 30, so here 28 plus 30 is plus 2. So here by splitting middle term, here this is the middle term. So here we have split in two parts. I have split the middle term in two ways. B in such a way B1, B2 such that B1 plus B2 is equal to B, and their product B1, B2 is equal to A into C. Right? So next we have second question based on factorization. So it is a very simple one. Again you have to find, and all these parts they are quadratic one. You have to find, even this question also you can find the roots. Find the roots. Right? Find the roots also. So here first part, that is x square go on solving, you can send your solutions. If you are, let me check. Sir, how to solve using completing square method? Okay. 4x square plus 3x plus 5. One question is from Puneet. He is interested at how to solve a question with completing square method. So, okay. If you want to solve that, or let me take the question is 4x, that is 4x square plus 3x plus 5. Question is completing square method. Let's take it. Question is 4x square, then we have plus 3x plus 5. We can solve it in two ways. Okay, because in the beginning 8 is a complete square already, 4 is a complete square, right? But the way you have solved, you can divide the whole equation by 4. So we get x square plus 3 upon 4x is equal to minus of 5 upon 4. Right? So don't get confused. I can explain both the ways. So in completing square method, what we have learned that here 1 it should be perfect square. 1 is the perfect square, although here is also perfect square. So I will let you know later on first with the same method. So coefficient of x is what? 3 by 4. In this way, what is the line of b? We are adding both sides. This implies that x square plus 3 by 4x plus 3 by 8 whole square. What we are doing? We are taking the coefficient of x is in terms of this b upon a. Right? So here we are writing that the value of b twice of a, 3 upon 8. Right? So here 3 upon 8, this is the completing square method. So here we are writing 3 upon 8 both sides. Now what we will do? We will write here x plus 3 upon 8 whole square, because it is a square plus b square plus 2ab. And here we will solve, that is minus 5 upon 4 plus 9 upon 64. So LCM here is, that is 64, 16 5s are. So here we have the answer, that is minus 71. I think yesterday also we have discussed. Now we have x plus 3 upon 8 whole square. Now this number minus 71 is negative. So how we are doing? We are taking under root both sides. Right? By taking under root both sides, we have x plus 3 upon 8 is equal to, that is plus minus under root minus 71 upon 8. So here we have the values of x is equal to, that is minus of 3 upon 8 plus minus under minus 71 upon 8. Or another way, we have the two roots, that is minus of 3 plus minus under 70 minus into 71 upon 8. But here in your syllabus or in grade 10, we don't have the numbers that minus, that is under root minus 71, right? So these are the imaginary numbers. Okay, we will study in or you will study in your higher classes these numbers. Okay, they will come in your quadratic, like the chapters and all. What like we are saying, that we discuss with you regarding nature of roots, nature of quadratic equations, roots of quadratic equations. We have the three cases, right? And it depends on the value of discrimination. So here the sort of, that is discriminant, sorry, the value of discriminant, we have a standard equation, like here we have the equation, that is ax square plus bx plus c is equal to 0. Standard form of quadratic equation. We know the roots are minus b plus minus under root b square minus 4ac upon 2a, right? 4, that is so Puneet is calling, we want to say something. Sir, how to get under root 17, get under root? My dear, I am saying this is not the part of your syllabus. Under root, these are imaginary numbers, you can say complex numbers. You will study in your classes, that is complex numbers, right? Complex numbers. Now, how to find, that is the some different concept, that iota. Okay, the imaginary number, that concept is totally different. That's what I am explaining here. When you have your these numbers minus first case, here b is equal to b square minus 4ac. Discriminant. When this b is greater than 0, we have the real and distinct roots. Second, we have b is equal to 0, real and equal roots. This is the third case. This is the third case when the value of b is less than 0. Right? The value of this b, what is the discriminant? Discriminant is b square minus 4ac. Right? So here you can check for this equation, a is 4, b is 3 and c is 5. When we have the value of b, the discriminant is greater than 0, we have two real and distinct roots. Two real and distinct roots. Like in the previous example, we have solved the value of x is 1 and the value of y is 2. By factorization, we have solved the two roots, one is 1 and another is 2. So both are distinct and real. Okay, you know what are real numbers. Real numbers means your natural numbers, whole number, integers, rational numbers, even irrational numbers. Roots of the equation can be in this form, under root 2 plus 3 or 7 minus under root 3. These are all real numbers, right? But under root minus 71 or under root like minus 1 or under root, these are your imaginary numbers. Second, when b is equal to 0 means two real and equal roots. Two real and equal roots. Two real and equal roots. Now this is the third case. A is 4, B is 3, C is 5. A is 4, B is 3 and C is 5. A is 4, B is 3 and C is 5, all are positive. Just check, find the value of D. For D, here we have the D is equal to B square. B square is 9 minus 4AC. So in this case, we have 9 minus 4, 4 are 16 minus 5, that is 80. So we have minus 71. So when the value of discriminant is less than, the value of discriminant is less than 0, you will write simply that the nature of roots, that no real root exists. When this is 0, here roots are real and distinct. Here roots are real and equal. And third case, the roots are imaginary roots. Or you will say no real root exists. No real root or roots exist. Either you can write no real root exists, or you will write that these are the imaginary roots. There is no need to solve. Just simply here, when the value of b is less than 0, you will write no real roots exist. What should be your solution? No real roots exist. Now if you are ready, or you can say these are the imaginary roots. So this is all about your. Now you are asking how to find the value of 1 root minus 71. So that is not the part of syllabus. These are some different concepts. Okay. This is related with your complex numbers. In grade 11 you will study this, the concept. Like your lower classes, we are studying first natural numbers, whole numbers, then integers. Then we are shifting in grade 9 on rational numbers, both rational and irrationals. And all these numbers are your real numbers. If we are saying that natural numbers, all natural numbers, 1, 2, 3 quantity numbers are natural numbers, then including 0, they are whole numbers. Then your integers, Z is the integers, means all positive negative numbers including 0. Then we are dealing with the next category, that is your rational numbers. Now rational number when we are talking about, irrational is something different. They are not in the category. But all numbers, they are the part of your real number. Right? Here this rational number we are denoting with Q also. And for real number we are denoting with R. R stands for the real number. Right? Means any number on the number line is a real number. Okay? So I hope you are very clear with this question. So come to this simple factorization. So topic wise, tomorrow we can revise, and in class I will give you test. Today is Wednesday, Thursday, Friday. So we have the continued class, or even decide tomorrow for some topics. WhatsApp me some topics, and we will conduct a class test. You can send me on WhatsApp, and later on I can check. Right? Or simultaneously we can discuss the questions. So come to these questions. So here we have first is x square minus of x minus 8. If this is equal to 0, if I am saying the quadratic, find the value of x. What are the roots? If you have solved, you can bearing transformation, probability and sets. The probability of sets. Okay, tomorrow we will take some of the questions. Please note down. Tomorrow we will going for the bearing and transformations. We will discuss some of the questions, and day after tomorrow on these topics we can, other students also, they can give your feedback. Puneet said that bearing, transformation and probability, and one more, that is sets, right? That is bearing, transformation, bearing, transformations, probability and sets, right? So we will discuss some of the questions tomorrow, and if possible then day after tomorrow also we will go for these topics, right? Now here middle term a into c, a is 1 here, b is minus 2 and c is minus 8. So here a into c is minus 8. So how to divide this middle term? We can write minus 2 can be written as 4 minus of 4x minus 2x. or we can say plus of 2x minus of 4x. So when we add, it will become, so we have split it in two terms, 2x in written as minus 2x in written as minus 4x plus 2x. So here we have x into x plus 2 and here we have x plus 2, right? So what is the sign here? Minus of 4. So we have two roots or two factors. One is x plus 2 and another is x minus 4. One is x plus 2 and another is x minus 4. So we have this implies that this is equal to 0, this implies that this is equal to 0. It means either x plus 2 is equal to 0 or x minus 4 is equal to 0. So we have x is equal to minus 2 and x is equal to 4. Right? X is equal to 2 and x is equal to 4. Minus 2 and 4. We have also a relation with the coefficients of this quadratic polynomial. If we have, please note down, if we have a quadratic polynomial ax square plus bx plus c, and let these are, one is alpha and one is beta. Let for the standard equation ax square and bx plus c, let alpha and beta are the zeros or roots, the zeros of the polynomial, zeros. Let the zeros are alpha and beta. Then we have the two relations, the sum of zeros and the product of zeros. This is an important relation. You should know that the sum of, I will check here for this equation, the sum of the zeros, sum of zeros, that is alpha plus beta, is always equal to minus of b upon a, and the product of zeros, please note down, product of zeros, that is alpha into beta is equal to c upon a. So here we have, let me verify it. Let me verify it. Here one root is minus 2 and alpha is minus 2 and beta is 4. So here the polynomial, quadratic polynomial is x square minus of 2x minus 8. Let's check. Here we have the value of a is 1, b is minus 2 and c is minus 8. So sum of roots, please check. Minus 2 plus 4, minus of 2 plus 4, that alpha plus beta is equal to, that is minus of 2 plus 4. It should be, it is equal to 2 only. But here let's check what is minus b upon a. Minus b is minus of minus 8 and a is, the value of a here is 1. How it is? Value of a here. Let me check again that here x is equal to 4 and okay, x is 4 and 1 is b is 2. Okay, thank you. Here x, this is the, alpha plus beta, 1 is minus 2 and 4, their sum is 2. And here minus b is what? Minus 2. So minus of minus b. Minus of, say, there is and what we have checked? The sum, that is minus 2 plus 4, that is also 2. Thank you, Pri. So we have verified the relation. Even product also. Product is alpha into beta is equal to c upon a. So that is minus of 8 upon 1 is minus 8. And when we multiply, 1 is minus 2 and 1 is 4. So here is minus of 8. So this is the result is verified. Even we can go for same, this is for first, second, all these, for all are already one, right? So we can go for all. So here, let's go for this relation. Like second one, here variable is s. The equation is 4s square minus of 4s plus 1. So little bit quick. So here a into c is 4. We can write that is 4s square minus of 2s minus of 2s plus 1. So taking common, that is 2s into 2s minus of 1, and here is 2s minus 1 minus 1 also. So what we have for two factors? We have 2s minus 1 and 2s minus 1. So in this case, we are finding the roots or zeros or 1, that s is equal to 1 by 2 and s here is 1 by 2. Both the roots, they are same. Alpha is also 1 by 2 and the beta is also 1 by 2. Right? But let's verify the result. The sum of roots is 1. Half plus half is what? 1. So alpha plus beta is 1. Let's check here. That is minus of b. Minus of b is minus of minus 4. Right? Upon a is 4, which is equal to 1. Right? It is equal to 1. So this is also verified, and the product is c upon a. So c upon a, that is 1 upon 4. So let's check. When we multiply 1 into 2, multiply by 1 into 2, we get 1 by 4. Right? If I am comparing with the quadratic equation, this part, second part, this is the equation. If I am writing here in this way, that this is the question 4x square minus of 4x plus 1, you will find or is equal to 0. In that case, the x is having the two zeros half and half, that is 0.5 and 0.5. And if you will go for discriminant, you will find it will be 0. You can check here that b square minus 4ac will be 0 here. B square minus 4ac is equal to 0. Right? So just need okay. Check b square minus b square, that is minus 4 whole square, and here is 4, a is 4, c is 1. So we have 16 minus 16 is equal to 0. So when b is 0, we have two real and equal roots. Two real and equal roots. Okay? We have two real and equal roots. So that I have related with your quadratic equations. Okay? Now third part. So I hope you are clear with the relations. Third part, that is, and in your examination 2-3 marks, this kind of factorization is always there. Please solve it and be quick. Minus 3 minus of 7x. Yes, please factorize the polynomial, quadratic polynomial 6x square minus 3 minus of 7x. It is important one. Why it is important? Because it is not in the standard form. This polynomial is not in the standard form. Please solve. I am not getting your responses. We can write it as 6x square minus of 7x minus 3. So here 6 into 3, 6 into minus 3 is equal to minus 18. So 9 and 2. We can write down here 6x square minus of plus of 2x minus of 9x, or we can rearrange in another way, minus 9x first and the 2x later. It is up to you. So here that is 3, 2 you can take outside, and here we have 3. So we can take 2x common, that is 3x, that is 6x square plus 1. 3 3s are 9. So here we have two roots, one is 3x plus 1 and another is, that is 2x minus 3. If we are finding the solutions or roots, we will find later on that x is equal to minus 1 by 3 and here x is equal to 3 by 2. Even we can verify, one that is alpha, one is beta. Okay, here A, B, C you can check. If I am correlating these A, B, C, the value of alpha, beta and gamma, so not gamma, alpha, beta. So here A is 6, A is 6, B is 7, minus 7 sorry, and C is minus 3. So here let's check the sum. If we are adding them, that is minus 1 by 3 plus 3 by 2. It should be equal to your alpha plus beta is equal to minus of b upon it. So what is my b? B is minus 7. A is 6. So this should be equal to 7 upon 6. So let's check. Here we have LCM 6. That is minus of 2 and here plus of 9, so which is equal to 7.6. So it is verified that the sum of these roots, that is 7. In product, what is the product? Their product is 1 by 3 into 3 by 2. It should be equal to the product of the zeros. 1 is minus, that is equal to C upon A. C is minus 3 and A is 4. C is minus 3 and A is not 4, A is only 6. That is 1 by 2 minus 1 by 2. So here also you will find the product of alpha into beta, that is minus 1 by 2. So here are the relationship of the coefficients that is verified. Okay. Whereas in case of our linear equations, if you for linear equation we have, this is the quadratic linear, that is ax plus b. We have only one root, that is x is equal to minus b upon it. Always. Although I am not given here cubic one, if we have a cubic polynomial, right? Then also we have three relationship. Then we have 3 cube, 3 zeros. If we have we have polynomial ax cube plus bx square plus cx plus d. A, B, C, D are the, like here we have A, B, C, here we have four constant A, B, C and D. So if we have cubic polynomial, then how many zeros we have? 3. Let these are alpha, beta and gamma. And we can also find with a different method these zeros. And what is about the relation? The relation is here we can know that sum of roots, product of roots sum is alpha plus beta plus gamma. That is always same like minus b upon a, right? Then we have one more relation, that is alpha beta plus beta gamma plus gamma alpha, right? That is equal to c upon a. And one more we have product of roots alpha, beta, gamma, that is equal to minus of b upon a. Okay, so these we can find, or there is this relationship always hold. Okay, so we have the last 5 minutes. Let's quickly discuss these questions. Next one we have fourth part, that is 4u square plus 8u. So here we can take 4u common, so we have u plus 2. So one we have this one and another is, so if 4u is 0, so u is equal to 0, because if we have 4u is equal to 0, this implies that u is equal to 0 upon 4, which is equal to 0. And if we have u plus 2 is equal to 0, means u is equal to minus 2. So what are the alpha? Alpha here is 0 and beta here is minus 2. And we can verify the same result. Alpha and beta, sum of roots or sum of these zeros is minus 2 and the product is 0. Alpha into beta is 0, because 0 multiplied by any number is 0, and the sum that is minus of 2. And you can check in terms of the coefficients A, B and C. Next one, we have t square minus 15. How to factorize it? T square minus 15. That is the fifth part, that is t square minus 15. We can go ahead, like one is, it can be written as t square minus of under root 15 whole square. I am writing a square minus b square. Any number x here, like 15 is there, 15 can be written as under root 15 whole square. So what I have, I can write it as t plus under root 15 minus into t minus under root 15. So what I am going to write here, that if we have a square minus b square, it is equal to a plus b into a minus b. Identity, right? So you have to remember these identities, a plus b whole square. We have the list of 9 identities. Okay, a plus b whole square, a minus b whole square. Then we have a plus b plus c whole square. Then we have a plus b whole cube, right? We have a minus b whole cube. And we have some separate identity, that is a cube plus b cube. We have a cube minus b cube. These are different identities. A plus b cube is a plus b into a square minus ab plus b square. Whereas here this is different. It is a cube plus b cube plus 3ab into a plus b. Right? So identities, you have to learn the identities. Okay, so with this I am ending today's class. Thank you very much, and please, those who are still watching, provide me the feedback how we can make our class more interesting. If you have doubts, please ask. Like for tomorrow, we will go for these topics: sets, probability, bearing, and transformation. So thank you very much. Stay blessed. I am ending the class.